a pioneer in hematology, groundbreaking research that revolutionized the medical world and contradicted a 1,500-year-old system. This is William Harvey, a defiant mastermind. The origins of hematology had been largely created by ancient Greek physicians, in particular Galen and Hippocrates. In the 5th century BC, Hippocrates wrote the book Hippocratic Corpus, which was the first attempt to methodize medical practices. In his book, various organs and experimental procedures are described, information which influenced other physicians, including Claudius Galenus. Galen, as he is more commonly referred to, was a physician in 157 CE. He was inspired by Hippocrates' work and began developing his own ideas. Among many others, his theories included that of urinalysis, the four humors, blood absorption, and heart valves. The culmination of these theories resulted in the Galenic system, a system which quickly became the standard for medicine throughout Europe. Galen's system led to the common belief of the four humors. This directly resulted in bloodletting being the main form of medical treatment. Galen practitioners believed that if a person was ill, it was as a result of imbalanced humors. In order to restore balance, the humor, either blood, phlegm, black bile, or yellow bile, must be drained. Thus, bloodletting, enemas, and purgatives became commonplace practices. Despite Galen's work being heavily reliant on philosophy, the lack of evidence against the Galenic system allowed it to perpetuate for centuries. Fast forward to 1600 in England, where a motivated young man by the name of William Harvey has just been accepted into the university at Padua. Harvey was an ambitious student and was eager to pursue a career in medicine. He studied with the renowned surgeon Hieronymus Fabricius, and in 1602 earned his doctorate. He then attended Cambridge, earned his practicing license, and became a fellow of the Royal College of Physicians. Harvey's impressive work earned him the position of physician extraordinary to James I in 1618. In addition to his professional life, Harvey was an avid researcher. His position as a lecturer at the College of Physicians allowed him to pursue his interest in circulation. By 1628, his extensive research led to the publication of his transformative book, De Motu Cordis. De Motu Cordis had proposed multiple shocking theories which gathered notable European attention. Harvey had described that blood circulated cyclically and was regulated by a closed system of veins and arteries. This idea directly contradicted the Galenic system, as well as the core beliefs of physicians and institutions at the time. Across Europe, these astounding discoveries were seen as a turning point in history. In England, King Charles I was quickly persuaded by Harvey's work. Being a royal physician, Harvey was a prestigious figure and greatly respected. But it was not only his reputation, but also his demonstrations that attracted the attention of many prominent figures. One of Harvey's demonstrations showed the purpose of veins. By tying a tourniquet around the subject's arm, Harvey could point to how the veins became engorged. As regulatory valves had previously been discovered, Harvey logically arrived at the conclusion that veins returned blood to the heart. This demonstration convinced the public and professionals alike that his theory was valid, and by the end of Harvey's lifetime, the theory of circulation had become the new standard of knowledge for medicine and was predominantly accepted in Europe.
Harvey's discovery is that the blood comes out of the heart into the arteries and right throughout the body, and then passes through little hair-like passages to the veins, and it's taken up by the veins and brought back to the heart. It circulates.
Furthermore, the way in which Harvey performed his experiments also fostered a shift in society. He was the first person to postulate new ideas using measurements and numerical data in association with observations. In one experiment, Harvey worked to invalidate Galen's claim that blood was absorbed by organs. Through the observation of animals' hearts, Harvey concluded that approximately 2 ounces of blood were ejected from the heart during every contraction. He then multiplied this number by 72, the average number of beats per minute in a human, and concluded that if blood were not reused 8,640 ounces would need to be produced per hour. This measurement far exceeded the total weight of a human and revealed the error in Galen's theory. This experiment also began Harvey's use of mathematical formulas, quantitative evidence, and data, which meant that his findings could be replicated. This created a standard of using evidence-based findings versus simply justifying results with philosophy. More researchers began using this method, including Richard Lower. Lower used Harvey's scientific principles to advance the study of veins and arteries, which contributed to the development of transfusions, notably in his experiments with transfusions between sheep and humans. However, despite growing acceptance of Harvey's theories, Galenic practices and theories flourished. Bloodletting continued to be a common practice by physicians well throughout the 1700s, despite Harvey's new research on the circulatory system. The continued use of outdated methods can be explained by examining the scope of Harvey's work. Harvey mainly focused on the big picture, such as how blood flowed, rather than the composition of blood. As a result, while Harvey's work did invalidate many of Galen's broader claims, such as the absorption of blood, he failed to disprove some of his more specific theories, notably the theory of the four humors. In addition, Harvey had also amassed a large group of skeptics. He found that many of his colleagues were eager to disprove his work and revealed that Harvey's work was not revolutionary, but rather a hindrance to medicinal development. Within this group were conservative physicians who were not willing to deviate from Galen's system and found themselves unwilling to compromise with new views. Others were merely spiteful or couldn't understand the implications Harvey's theory held. One of Harvey's greatest critics was Jean Riollon. Jean Riollon was a notable anatomist who continued to subscribe to the beliefs of the Galenic system. In 1649, he published a book attempting to disprove Harvey's theory of circulation. In Opuscula Anatomica, Riollon uses animals during hibernation as his rebuttal. He argued that these animals' hearts do not beat while they are hibernating. Thus, if Harvey's theory was correct, they would promptly die. Another criticism Riollon made was in regard to fetuses. He stated that for the heart to pump, a constant supply of blood would be necessary. However, as the heart has not fully developed in pregnancy, it would be impossible for circulation to occur. Thus, Riollon said that circulation could not sustain life, as Harvey had claimed. Riollon's book expressed the contradictions that some scientists held at the time and was one of many voices that wanted to suppress Harvey's ideas. In response to this backlash, Harvey wrote 2 letters to Riollon stating his rebuttal. He discussed how Riollon had no basis to contradict Harvey, and he had heard criticisms from the moment he published his book. In his letter, Harvey writes, "But I think it a thing unworthy of a philosopher and a searcher of the truth to return bad words for bad words. I shall wipe away those symptoms of incivility." It becomes explicitly clear how Harvey disregards Riollon's criticisms against his publication. Harvey held complete faith in his theories and was not going to succumb to the harsh criticism of others. While the impacts of Harvey's work may not have been fully realized during his lifetime, his perseverance blazed the trail for modern medicine. Modern advancements would not have been possible without his theories on circulation and his work on arteries, veins, and blood ejection from the heart. Without these discoveries, advanced procedures could not be performed. For example, open heart surgeries now require continual monitoring of blood flow due to Harvey's theory of circulation. Similarly, dialysis machines, heart assistants, and other life-saving devices also use this theory to keep patients alive. Biologist Carl Landsteiner's discovery of A, B, O blood groups proved that blood transfusions can only occur safely if blood is properly circulated. He used Harvey's theory to make transfusions more effective and prove their safety. Additionally, scientists now focus on data versus philosophy to justify their findings, yet another result of Harvey's evidence-based experimentation. William Harvey's discoveries were undoubtedly turning points in history. His book De Motu Cordis rapidly caught the attention of the public with its sound reasoning and comprehensive experimentation. Despite his theories opposing a 1500-year-old system, Harvey mustered the courage to present his experiments and handle a flood of of backlash. He revolutionized the medical field by incorporating data and scientific reasoning into his experiments, thus beginning to draw away from the typical philosophy-based explanations. Harvey's proposal of circulation heavily influenced the research of other physicians and established a new basis for physiology across Europe. While Harvey might not have lived to see the full impact of his research, he was a pivotal figure in medicine, and modern society's understanding of hematology would not be possible without him. Today, he is fittingly remembered as the father of physiology and medicine. William Harvey was truly a defiant mastermind.